Hello friends, once again welcome to chemistry classes by Vijay Kumar Sethi, class 11th chemistry. Now we will start the unit 11, the P block elements, and in this we will discuss about the general introduction of P block elements. Now what are P block elements? In P block elements, the last electrons enters the outermost p orbital. It means elements in which last electron enters the p orbital are known as P block elements. Except helium, the number of p orbitals is 3, and therefore the maximum number of electrons that can be accommodated in a set of p orbital is 6. Consequently, there are 6 groups of p block elements in the periodic table, numbering from 13 to 18. Boron, carbon, nitrogen, oxygen, fluorine and helium had the groups. It means these are the first member of these groups. Their valence shell electronic configuration is ns2, np1 to 6 except for helium. The maximum oxidation state shown by a p block element is equal to the total number of valence electrons, and this is called as group oxidation state. See this table. These are the p block 13 p block groups 13, 14, 15, 16, 17, 18. This is general electronic configuration, outermost shell. These are the first member of the group: boron, carbon, nitrogen, oxygen, fluorine and helium. Group oxidation state plus 3. Actually, the number of valence electron 2 and 1. So this is 3. In the same way, this is plus 4, plus 5, plus 6, plus 7, plus 8. Other oxidation states are these. Clear? The oxidation state 2 unit less than the group oxidation state becomes progressively more stable for the heavier elements in each group due to inert pair effect. It means if we go down the group, okay, the oxidation state 2 unit less than the group oxidation state is more stable. For example, in case of group 13 element, group oxidation state is plus 3, but if we go down, the plus 1 oxidation state is more stable. The same way, for group 14 element, plus 4 is the group oxidation state, but if we down the group, plus 2 oxidation state becomes more stable due to inert pair effect. Now question arises, what is inert pair effect? This is reluctance of the ns2 electron to participate in bond formation of heavier members of p block elements is called inert pair effect. Actually, energy required to unpair the ns2 electron is not compensated in bond formation. Okay, simply down the group, to unpair the electrons present in ns orbitals, we have to supply the energy, and this energy should be compensated in the bond formation using these electrons, but the energy required to unpair these ns electrons is more, which is not compensated in the energy released during bond formation. So these electrons present in ns orbital are not take part in the bond formation. Okay, so this is called inert pair effect. In p block elements, metallic and non-metallic characters, how do changes? As we know, in p block elements, metals, non-metals and metalloids are present. See this periodic table. These are the metals indicated by this color, metalloids. Okay, this is borderline. Elements situated near the borderline are metalloids, and these are the non-metals. Clear? So all 3 type of elements, metals, non-metals and metalloids are present in p block elements. The non-metallic character of elements decreases down the group. In fact, the heaviest element in each p block group is the most metallic in nature. In general, non-metals have higher ionization enthalpies and higher electronegativities than the metals. Hence, in contrast to metals which readily form cations, non-metals readily form anions. The compounds formed by highly reactive non-metals with highly reactive metals are generally ionic because of large differences in their electronegativities. On the other hand, compounds formed between known metals themselves are largely covalent in character because of small differences in their electronegativities. The non-metal oxides are acidic or neutral, whereas metal oxides are basic in nature. Even some metal oxides are amphoteric in nature. First element differ in some respect from rest of the members in a group due to non-availability of d orbitals, smaller size, high charge to radius ratio, and high electronegativity. Now we will discuss some important aspects regarding p block elements. The second period elements of p groups starting from boron are restricted to a maximum covalency of 4 because there are only 4 orbitals in the second period element, and so they use 2s and 3 2p orbitals. That is, one orbital present in the 2s subshell and 3 orbitals present in the 2p subshell. So their covalence is maximum 4. In contrast, using d orbitals, the third period elements can expand their covalency above 4. For example, boron forms only Bf4 negative, aluminum gives AlF6 3 minus ion. In this Bf4 minus, the covalency of boron is 4, while in this AlF6 3 minus, the covalency of aluminum is 6. The first member of a group differs from the heavier members in its ability to form p-pi multiple bonds to itself. Multiple bond means double bond and triple bond. And as we already discussed, when double bond and triple bonds are there, pi bonds are also present. Clear? And these pi bonds, especially in case of first member of these p block elements, that is pi bond is formed by the p-pi. Okay, p-pi means they are using p orbitals during the formation of pi bonds. For example, this is carbon-carbon double bond, carbon-carbon triple bond, nitrogen-nitrogen triple bond, and two other second row elements. For example, carbon with oxygen double bond, carbon with nitrogen double bond, carbon with nitrogen triple bond, nitrogen with oxygen double bond. The heavier elements do form pi bonds, but this involves d orbitals. So we can say d pi p pi or d pi d pi. However, the coordination number in species of heavier elements may be higher than for the first elements in the same oxidation state. Okay. Now, what is the meaning of this coordination number? Coordination number means nearest surrounding atoms. Okay. Coordination number means number of the nearest surrounding atoms. For example, in +5 oxidation state, both nitrogen and phosphorus form oxoanions like NO3 minus. This is the oxoanion of nitrogen. Okay. In this case, 3 coordination with pi bond involving one nitrogen p orbital. You can say this is nitrogen is surrounded by the 3 oxygen atoms. So its coordination number is 3. But in case of phosphorus form PO4 3 minus. Again, in this case, the oxidation state of phosphorus is +5. But this is 4 coordination involving S, P and D orbitals contributing to the pi bond. Mnemonics for the p block elements. These are some shortcut method. How can we remember these p block elements? Actually, these we already discussed in the classification of elements when we discussed the block classification. Just for the revision, you can again memorize these. Group 13 elements: boron, aluminium, gallium, indium, thallium. They can be remembered like this: bengan, alu, gajar, in, thela. Group 14 elements, also known as carbon family. K, that is carbon. C, Si, O, G, Ge, germanium. Sun, Sn, okay, of pub, that is lead, Pb. Group 15 elements, nitrogen family, and these are also known as the nitrogens. nitrogen, phosphorus, arsenic, antimony, bismuth, and you can remember नहीं, पसंद, ऐसे, सब, भाई. Okay, NPASSBBI. Group 16 elements, the oxygen family, and these are also known as the chalcogens. Oxygen, sulfur, selenium, tellurium, polonium. Okay, you can make one sentence. OSCETPO. OSCETEPO. Group 17 elements, the halogen family, fluorine, chlorine, bromine, iodine, astatine, and they can be remembered. फिर F, कल Cl, बाहर Br, I for iodine, anti AT, फिर कल बाहर I, anti FCl, Br, I, AT. Group 18 elements, these are known as noble gases. Helium, neon, argon, krypton, xenon, radon, Hene or Karjiran, HENE, Hene or AR, Kar KR, GXE, Run RN. Okay, thank you. Subscribe my channel to get the next video from this chapter.